Alright, this is a very exciting video because we'll be looking at dividing polynomials by each other. A brand new technique. Before we do that, we do need a refresh on dividing numbers with each other. So this one here, what we're trying to do is 4285 divided by 5. So that's how we read off that notation. If we do that, we basically need to take the 5 in and think about how many times it goes into each thing in this right-hand side. So can you do 5 times something to get up to 4? You can't really. But what we do need to look at is this first bit, which is 42. So if you have a think about it for a little while, you'll spot that 5 times 8 is 40. Now that is as close as we can get to 42 without going over. So I'm going to put the 8 up there that I times the 5 by. And then basically what you do once you have that 8 is you do 8 times 5 like this. You get 40 and you put that in underneath. Alright, so we're going to subtract these two away from each other, and I'm left with 2. And then the 8 comes down and sits with the 2 here. Now I basically got to do 5 times something to get towards 28. And if you think about it for a little while, you'll get 5 times 5 is 25. That's as close as you can get to 28 without going over. So that number I have to put there is 5. So again, we'll do 5 times 5 here to get 25. Subtract those, you get 3. And the 5 can come down. And if you think about this one, you'll get 5 times 7 gives you 35. And hey, we actually hit 35 exactly. That's good news. So 7. If basically what we've worked out is that 4285 divided by 5 is 857. And if we do that, we should actually get that answer. So yes, we do. That's good news. All right, this one is a different example. So we got to think about how many times does 2 go into 3 there? Well, it goes in once, and then we can do 1 times 2. Subtract that, and we're going to get 1. We pull the 2 down to get 12, and we can think about 2 times maybe 6 would give us 12. So that 6 is the number we want there. And then we're going to do 6 there. So basically what we've got to do for this one is 6 times 2 is 12. We've actually hit it exactly, so we're going to have 0 left over. Moving down, we're going to pull the 1. So essentially we've got 2 times something. We're trying to hit 1, but we can't. We're going to go over as soon as we do 2 times anything. So it's actually 2 times 0. It gives you 0. So I'll put a 0 up there. And then technically what you've got to do is you've got to do 2 times 0 underneath. Subtract them, but you're going to get 1. And that number there, we call the remainder, because that's what we have left, because we've sort of run out of digits here to do anything more with. We have nothing to pull down after the 1. So if we wanted to write this out, I guess formally, we tend to say that 321 divided by 2. At least when you first learned long division, you probably said something like this. So 160 and then little r and then 1. So there's a remainder of 1. How we're going to do it in this topic is a little bit more precise. So it's 160 plus the remainder is 1 over, and the number we were trying to divide by is 2. So that's how I want you to write it in year 12. All right, so essentially if we do 321 divided by 2, what we should see is we get 160 and then it's 0.5 because you've got the extra half on the end. All right, so that was number division. Now let's divide some polynomials, and it's pretty much the same process, almost surprisingly. So with this one here, we've got to do x cubed, 5x squared, plus 6x. And I really should be putting plus 0 on the end, because you want to make it go all the way down to your constant term. And then x plus 3 just sitting up here. All right, so basically what you do is you don't worry about the plus 3. You do just look at the x bit and how many times does x go into x cubed. So x times by, well, we could times it by x squared to get x cubed. So that's the number that we want to put up top. So that's exactly what we're going to do, x squared. Then once you've done that, we need to take the x squared and times it by all this stuff here. So if I do the first term, I'm going to get x squared times x, that gives me x cubed. And then I'm going to get x squared times 3. So that gives me 3x squared. And as you do this step, try and have all your cube powers and your squared powers all lined up with each other, because we're about to subtract them. I get nothing there, so I won't even write it in. But here, I'm going to get 2x squared left over. 5 take 3. The 6x comes down, and then we repeat. So the next question I'll ask is, well, x times something would have to give you 2x squared. What would that be? Well, it would be 2x. That's the number we're looking for there. So that's the next number we're going to be putting on here. And then we'll repeat the process. So 2x needs to times by the whole thing. If you've done it right, it should always work out that, 2x times x gives you 2x squared. It should always work out that these two match and cancel off to 0. If they don't, something has gone wrong. Anyway, once you've done that, you can do 2x times 3 to get 6x. Now, I actually can subtract these and get 0. So we're basically done. You can pull down the 0 here and then just put a plus 0 on the end there. But that doesn't really do much, so I'm not going to bother. All right, so essentially what we've learnt is that if I take x cubed plus 5x squared plus 6x, and I divide it by x plus 3, I have got x squared plus 2x. So we've just figured that out. Just a little bit of notation stuff. Generally what we do is we call this thing here p of x. We call this thing here d of x because we're dividing by it. And we call this thing here q of x because it's a quotient. If you have a remainder, you call that r as well. So we'll work with this little statement and we might actually just verify that it's true. So I'm claiming that this is true. And if you think about rewriting this, you could actually times both sides by x plus 3. So you've got x cubed plus 5x squared plus 6x equals x plus 3 with x squared plus 2x. And this is sort of what I'm claiming to be true from the division. And we can actually expand this out to double check. So if we do that, then we can expand. So I get x cubed, I get 2x squared, I get 3x squared, and I get 6x, which if I simplify that down, that is exactly what the left-hand side said. So yes, we know that's correct. You might actually be spotting right now that polynomial division is going to help us factorize polynomials a lot nicer. Because as soon as you know that x plus 3 is a solution to that cubic essentially, or a factor of the cubic, you can divide out to get the other factor. All right, now let's try this polynomial division. So we're putting x plus 3 over here, and I've got x4 plus 2x squared, take 1. But if you try and do it like that, you're going to run into trouble because you need to always just continue down the powers. So 4, 3, 2, 0x, so 1, and then the constant term. If you don't put those in, the division just doesn't work. So we've got to think, how many times does x go in x4? It goes in x cubed times. Then we take x cubed and we times it by both bits. So that's going to give us 3x cubed. And now you can see why I put the 0 in, hopefully, because we do have to do that subtraction, just like that. Anyway, pull down the 2x squared, and then we're off to our next bit. So how many times does x go into minus 3x cubed? It goes in minus 3x squared times. So then we need to take the minus 3x squared there and times it by each term. So you're going to get minus 3x cubed. Remember, they should always match. And you're going to get minus 9x squared for that next bit. Subtract those from each other. The first term will cancel off, as we should hopefully expect. And then 2 take away minus 9 gives you 11x squared there. I'll pull down the plus 0x here. And then same process. How many times does x go into 11x squared? Well, it goes in 11x times. Then we can do that. So we're going to be left with 11x squared plus, and then 11x times 3. So that is 33x. Subtract them away from each other. Pull down the minus 1. And then we can repeat our process. How many times does x go into minus 33x? Well, it goes in minus 33 times. So then we just need to do this times by that. So your first term is going to be minus 33x. That matches. It's good news. And then your last term is going to be minus 99. If we then subtract these from each other, you're going to get minus 1, and that turns into plus 99. So you get 98 as your remainder there. And we have a remainder. So it is absolutely possible to get remainders in polynomial division. The way that I would write this out formally is that x to the 4 plus 2x squared take 1 over x plus 3 is the answer that we got. So that is x cubed take 3x squared plus 11x take 33. Plus your remainder, so that's 98, over the thing we were trying to divide by, x plus 3. So that's in full how you could write it out. And if you want that stuff just to be labeled as well, because it's good to have notation around this that supports it. So the very top thing we called p of x. This bottom thing we're calling d of x. This thing in here is q of x. That's the quotient that we got. This thing here we just call normal r. But you got to be really careful, because sometimes if you're dividing by like a quadratic or something, r could be like a linear function. In fact, if you're into degrees of polynomials, this thing here that we're dividing by is a degree 1, and then this thing here is a degree 0. So the remainder is always 1 less degree than what you're trying to divide by. So sometimes this is r of x. But in our case, it's just a constant. Anyway, this is another d of x on the bottom. So that's one way to write it. If you want a little extra way to write it, so we might go or, you could times everything by x plus 3. So an alternate version would be the x to the 4 plus 2x squared take 1 is x plus 3 with that result that we got, x cubed take 3x squared plus 11x take 33. And then just plus 98.